Hello and welcome to yet another video. So in this video, we'll be discussing about quietly confused or more confused terms, which are often confused with each other and are used interchangeably, but are probab but are not the same. So today we'll be discussing about probability versus likelihood. So So what is probability? So probability is measure of likelihood that a specific event will occur out of a set of possible outcome. It is always a number between 0 and 1, where 0 indicates that a particular event will not at all occur, and 1 represent that event will occur with certainty. So next we have some mathematical definition for probability, like for a random variable x taking values x, the probability of taking a specific value x is denoted as px equals to x, and it is represented as px equals to x is equals to fx. And we can see one examples, like if we consider a pair-sided, six-sided die, the probability of rolling a three is probably is 1/6, because one face has a number three and total possible outcome is six, so 1/6. Next, what is likelihood? So we'll just understand first the definition, then we'll go to uh, some uh, some distribution, some continuous distribution, and we'll be seeing with the help of one graph, and we'll be able to understand more better. So likelihood is a concept that is used in statistical inference to measure how plausible a specific set of parameter is given observed data. So here we already have our data for which we want to find how possible it is to find that value given a distribution. So it is not a probability, but a function of the parameter of a statistical model. For observed data D and statistical model parameterized by theta, the likelihood L theta by D is the probability of the data given the parameters. So this will be more clear when we see the distributions ahead. So this is the equation for likelihood, like see how likelihood and probability are basically interchanged. L theta given D is equals to probability of D given theta. So basically it is interchanged. So here is one example also. So suppose we have a set of coin toss results, head, tail, and we want to estimate the probability of theta of getting heads. The likelihood of theta given the data is represented by following equations. So next, what is the key difference between probability and likelihood? So probability starts with a known parameters, like we should know the mean and standard deviation if we are considering a normal distribution in advance, and computes the likelihood of different outcomes. And likelihood starts with observed outcomes and computes the plausibility of different parameters. So functionality, like probability is represented Px, it is equals to certain value at a given x, and likelihood is a function of some parameter theta. So uh, we'll like we can see how probability works in case of a normal distribution. So consider a random variable x following a normal distribution with mean mu and standard deviation sigma. The probability density function of a value is given fx given mu and sigma. So it is represented by following equation. And whereas in case of likelihood, given a set of observed data, the likelihood function for the parameter is just reverse of that probability. Like here we will write likelihood of mu and sigma given the data. So this capital sigma, it is used for this is a multiplication operator between different durations. So this likelihood is used later on. We'll also see in some logistic regression where it is used for estimating maximum likelihood estimation. So here with the help of example, we can see that probability is basically area under certain curve. Like if we want to find the value falling between a particular range, like 170 is a probability, then we need to calculate the area between the curve. And likelihood is like what is the value of y given certain fixed value, like what will be the value of uh, value on this y-axis, given a certain value here on x-axis, like what will be the value of y, the function, given the x value is 177 or so. So this was the some of the differences of between probability and likelihood, and this is true for all continuous functions. So stay tuned for more such updates and videos. Thank you.